learning objectives. At the end of this topic, you will be able to explain compound interest and yet using a formula for compound interest. Calculate rate compounded annually or half-yearly. Describe applications of compound interest formula. Welcome to the chapter Compound Interest. Do you know what interest is? Interest is nothing but the fee charged by a lender to a borrower for the use of borrowed money. There are two kinds of interests, simple interest and compound interest. You have already learned what is simple interest in your earlier class. Do you remember what simple interest is? Yes, very good. A quick method of calculating the interest charge on borrowed money. Simple interest is determined by multiplying the interest rate by the principal by the number of periods. The next one is compound interest. Compound interest is interest added to the principal of a deposit or loan, so that the added interest also earns interest from then on. This addition of interest to the principal is called compounding. We will briefly discuss about compound interest in this chapter. Interest is the extra money paid by the banks and post offices on money deposited with them. Interest is also paid by people when they borrow money. Now let us see an example on how to calculate compound interest. Calculate compound interest on the amount of rupees 4,500 at 10% per annum in 2 years. First, find the simple interest SI for 1 year. Let the principal for the first year be P1. Here P1 is equal to rupees 4,500. SI1 is equal to simple interest at 10% per annum for the first year is equal to rupees 4,500 into 10 whole divided by 100. Cancel two zeros in the numerator and the denominator. We have 45 into 10. When we multiply this, we get rupees 450. Then find the amount which will be paid or received. This becomes the principal for the next year. Amount at the end of the first year is equal to P1 plus SI1, which is equal to rupees 4,500 plus rupees 450. Adding this, we get 4,950. We consider this as P2, that is, principal for the second year. Again, find the interest on the sum for another year. SI2 is equal to SI at 10% per annum for second year, which is equal to 4,950 into 10 whole divided by 100. Cancel the zeros in the numerator and denominator. We get rupees 495. Now find the amount which has to be paid or received at the end of the second year. Amount at the end of the second year is equal to P2 plus SI2, that is principal for the second year, is 4,950 plus interest for the second year is 495. Adding this, we get 5,445. Therefore, the total interest is equal to rupees 450 plus 495 is equal to rupees 945. You may get a doubt if compound interest is same as simple interest. Now let's calculate to clarify this issue. As you know, the formula for simple interest is equal to PNR by 100. Simple interest for 2 years is equal to rupees 4,500 into 10 into 2 whole divided by 100. Cancel the zeros in the numerator and denominator. Now multiply 45 into 10 into 2 we get rupees 900. The difference between compound interest and simple interest is rupees 45. So what does it tell you? Compound interest is always greater than simple interest. Deducing a formula for compound interest. Children, you may have a question. Is there an easier way to find compound interest? Yes, we have. You can also find compound interest by deducing a formula for compound interest. Formula method. Let us try to find out. Suppose P1 is the sum on which interest is compounded annually at a rate of R% per annum. First, find the simple interest for the first year. So, SI1 is equal to rupees P1 into R into 1 divided by 100, where P1 is the principal for the first year, and R is the rate of interest, and 1 is the number of year. After calculating simple interest for the first year, then find the amount for the first year. So, the amount at the end of the first year A1 is equal to P1 plus SI1. Substitute SI1 here, so it becomes P1 plus P1 R by 100. Taking P1 commonly outside, we get P1 into 1 plus R by 100. We consider this as P2, that is, the principal for the second year. Again, calculate simple interest for P2. SI2 is equal to P2 into R into 1 divided by 100. Substitute the value of P2 here, so it becomes P1 into 1 plus R by 100 into R by 100. This we can write it as P1 R by 100 into 1 plus R by 100. Now calculate the amount at the end of the second year. A2 is equal to P2 plus SI2. Substitute the value of P2 here, so it becomes P1 into 1 plus R by 100 plus P1 R by 100 into 1 plus R by 100. Taking P1 into 1 plus R by 100 commonly outside, we get P1 into 1 plus R by 100 into 1 plus R by 100. Here, 1 plus R by 100 occurs 2 times, so we write it as P1 into 1 plus R by 100 the whole square. We consider this as P3. Proceeding in this way, the amount at the end of n years will be AN is equal to P1 into 1 plus R by 100 the whole power n, or we can say A is equal to P1 into 1 plus R by 100 the whole power n. Using this formula, you can find the compound interest in a shorter way. Now we calculate compound interest by using the formula. Consider the same example as we did before. Calculate compound interest in amount in rupees 4,500 at 10% per annum in 2 years. We know principal P is equal to rupees 4,500. R, that is the rate of interest, is equal to 10%. Number of years n is equal to 2 years. Consider the formula. A is equal to P into 1 plus R by 100 the whole power n, where A is equal to amount, P is equal to principal, I is equal to interest, R is equal to rate of interest, n is equal to number of years. Now let us substitute the given instructions in this formula, so it becomes A is equal to 4,500 into 1 plus 10 by 100 the whole square. Next, the 4,500 be as it is inside the brackets. Take the LCM of 1 plus 10 by 100. We get 100 plus 10 whole divided by 100 the whole square, which is equal to 4,500 into 110 by 100 the whole square. Now cancel 1 0 in the numerator and denominator. Divide 11 by 10. We get 1.1. So we write it as 4,500 into 1.1 the whole square is equal to 4,500 into 1.21. Since 1.1 the whole square is equal to 1.21. Now multiply 4,500 into 1.21. We get 5,445. To find the compound interest, subtract amount and principal. Therefore, compound interest is equal to A minus P, which is equal to rupees 5,445 minus 4,500. Subtracting this, we get rupees 945. Rate compounded annually or half-yearly? How will you calculate compound interest if the rate is compounded annually or half-yearly? Now let us do a few example problems related to rate compounded annually or half-yearly. Consider the example. Find the amount of rupees 8,000 for 3 years, compounded annually at 10% per annum. Also find the compound interest. Here, P is equal to rupees 8,000. R is equal to 10% per annum. N is equal to 3 years. Using the formula A is equal to P into 1 plus R by 100, the whole power N. We get amount after 3 years is equal to rupees 8,000 into 1 plus 10 by 100, the whole power 3. Always solve the calculation which is inside the brackets first and then multiply with the remaining values. So here, 8,000 be as it is. Take the LCM of 1 plus 10 by 100. We get 100 plus 10 by 100, the whole power 3, which is equal to 8,000 into 110 divided by 100, the whole power 3. Cancel the zeros in the numerator and denominator. Now we have 11 by 10, the whole power 3. We can also write 11 by 10, the whole power 3 as 3 times of 11 by 10. So it becomes rupees 8,000 into 11 by 10 into 11 by 10 into 11 by 10. Now cancel all the zeros. We get 8 into 11 into 11 into 11. When we multiply this, we get rupees 10,648. To find the compound interest, subtract the amount in principal. That is, rupees 10,648 minus 8,000. We get rupees 2,648. Now consider the next example. Find the amount and compound interest on rupees 8,000 for 1.5 years. At 10% per annum, the interest being compounded half-yearly. Principal for first 6 months is equal to rupees 8,000. There are 3 half years in 1.5 years. Therefore, compounding has to be done 3 times. Rate of interest is equal to half of 10% is equal to 5% half-yearly. A is equal to 1 plus R by 100, the whole power N is equal to rupees 8,000 into 1 plus 5 by 100, the whole power 3. Now cancel 5 20 times is 100. Then take the LCM. We get 21 by 20. So it becomes rupees 8,000 into 21 by 20, the whole power 3 is equal to rupees 8,001 by 20 into 1 by 20 into 1 by 20. Cancel all the zeros. Then cancel 2 times 4 is 8. Again cancel 2 times of 2 is 4. And finally cancel 2 times 1 is 2. Now multiply all the 21s. Hence the amount is rupees 9,261. Interest is generally calculated on a yearly basis. Sometimes it can be compounded more than once within a year. It can be compounded half-yearly, which means twice a year, or quarterly, which means 4 times a year. Amount when interest is compounded half-yearly, you can also use the formula A is equal to P into 1 plus R by 200 the whole power 2n, where R by 2 is half-yearly rate and 2n is equal to number of half years. Amount when interest is compounded quarterly, you can use the formula A is equal to P into 1 plus R by 400 the whole power 4n, where R by 4 is quarterly rate and 4n is equal to number of 1/4 of the years. Applications of compound interest formula. There are some situations we use the formula for calculation of amount in compound interest. Here are a few. Increase or decrease in population. The growth of a production if a rate of growth is known. The value of things if its price increases or decreases in the intermediate years. Consider the example. The present population of a village is 18,000. If it increases at the rate of 5% per annum, what will be the population after 3 years? In every year, there is 5% increase in population, so every new year has new population. Thus, we can say it is increasing in compounded form. Here, P is equal to rupees 18,000 and R is equal to 5% and N is equal to 3 years. Population after 3 years is equal to rupees 18,000 into 1 plus 5 by 100 the whole power 3. As we did earlier, first simplify inside the brackets. So we get rupees 18,000 into 21 by 20 the whole power 3. Now we can write this as 18,000 into 21 by 20 into 21 by 20. Cancel all the zeros and cancel 2 times 9 is 18. Now multiply the numerator and then divide by the denominator. We get 83,349 divided by 4. It becomes 20,837.25. Hence, the estimated population at the end of 3 years is equal to 20,837.25. You may get a doubt how to calculate compound interest if the value of an item decreases in the intermediate years. Let us consider another example. A refrigerator was bought at a price of rupees 15,000. After 1 year, the value of the refrigerator depreciated by 5%. Find the value of the refrigerator after 1 year. Principal is equal to rupees 15,000. You know depreciation means reduction of value due to use and the age of an item. Here the reduction is equal to 5% of rupees 15,000 per year. First we calculate 5% of 15,000, that is 15,000 into 5 into 1 by 100. Cancel 2 zeros in the numerator and denominator and then multiply the remaining terms. We get rupees 750. So the value at the end of the first year is equal to rupees 15,000 minus rupees 750, which is equal to rupees 14,250. Alternately, we may directly get this as follows. Value at the end of the first year is equal to rupees 15,000 into 1 minus 5 by 100. Cancel 5 20 times is 100 and then take the LCM. So it becomes rupees 15,000 into 19 by 20. Cancel 1 zero in the numerator and denominator and cancel 2 times 750 is 1,500. Then multiply 750 into 19 is equal to rupees 14,250. Summary. Let's summarize the topic. Compound interest is calculated on the principal and the interest for the previous period. When interest is compounded annually, the total amount is calculated using the formula A is equal to P into 1 plus R by 100, the whole power n. Interest is generally calculated on a yearly basis. Sometimes it can be compounded more than once within a year. It can be compounded half-yearly, which means twice a year, or quarterly, which means 4 times a year. When interest is compounded half-yearly, A is equal to P into 1 plus R by 200, the whole power 2n, where R by 2 is half-yearly rate and 2n is equal to number of half-years. When interest is compounded quarterly, A is equal to P into 1 plus R by 400, the whole power 4n, where R by 4 is quarterly rate and 4n is equal to number of 1/4 of the years. When the value of an item depreciated, the total amount is calculated using the formula A is equal to P into 1 minus R by 100, the whole power n.